Hello, everyone, and welcome to episode 12 of Nelson's Corner. We're going to be continuing on with our card game engine that Nelson is putting together. This will be part 3. Now, joining us tonight, we've got Mr. Zach Parrish.
Hello.
And Mr. Smooth Butter himself, Nelson. Hey, for those of you that are curious about the Smooth Butter comment, just listen to last Friday's radio show, and you will be up to speed with Mr. Smooth himself.
Now, if you must.
Tonight, continuing on with this card game engine, tonight's going to be a focus on some architecture. As a matter of fact, this will be our first look into Nelson's mind as far as what he has in mind for architecture. Now, Zach is going to be piloting the Wacom tablet from some 2,500 miles away, and this should be interesting.
Yeah, so if something gets lost in translation, it's totally my fault.
The system as it's coming together is slowly becoming, a bit more complex for someone who looked at it for the very first time. And I'm saying that because we just looked at it a few minutes ago for the very first time, and Nelson has to get across to Zach exactly what to draw on the screen. So this should be a lot of fun, but please bear with us as we work our way through this episode. So Nelson, architecture discussion. Now, I heard earlier when we were just kind of kicking back and chatting, you had talked about there were two architectures that we needed to talk about. We had pre-game and actual runtime game. Is that correct?
Well, yeah, I first do want to say one thing, though.
Sure.
What we're going to be building initially is going to just be the card engine. I'm not putting any forethought into the tools used to construct decks at this point. Mm-hmm. I just want to point that out. If somebody doesn't see any deck construction stuff, drawn up on the board, don't be confused. I'm dealing with that later.
Definitely don't be confused. Back up and listen to the beginning of this video and the other videos where I say Nelson continues with the creation of the card game engine.
Yes. Yeah. Okay, but yes, you can separate the code that we're going to be writing into two sort of categories. One is going to be smaller, but still pretty important, and the other one's going to contain the bulk of the code. And the first part that we're going to be dealing with, and the first part that we're going to be writing, is kind of the pre-game stuff. I guess that's the term that we came up with.
Mm-hmm.
Okay.
In my code, before we sat down, I kind of called it the environment. Basically, the responsibility of the pregame stuff is to create or to load into memory and to establish what every card that is available to the system is, and to organize those cards into particular decks.
Okay.
So those are the two big responsibilities of the pregame stuff, and that's what we're going to be working on first, because obviously we can't really work on an engine much if we don't have cards that we can play with. The second sort of category area, doohickey, is going to be the runtime, and that's the code that's going to be responsible for, actually running the game. And right now, on this particular diagram that Zach is drawing, it's just going to be basically everything else. What happens as you're playing the game.
Okay.
And so I just wanted to point out that that's the approach that I guess we're taking.
So the architecture that we're going to be looking at tonight is going to be pre-game, overall, runtime?
Well, I say we go ahead and look at everything.
Okay.
Try to maybe squeeze most of it into...
So we can say the big picture.
Yeah, the big picture, I guess. And then we can go and talk about the runtime more in depth and the pregame more in depth once we get to implementing those particular components.
Okay, awesome.
So in terms of the pregame, where are we going to be kind of starting out? Or is that actually where you want to begin?
No, we're going to do the big picture first.
All right.
So we're going to get into pregame, then runtime a little bit later. But right now, he just kind of wants to give a view of the big picture, the whole thing. So do we want to scroll down, Nelson, below code categories and put big picture?
Yeah, just another H1.
Okay, another H1.
Nice.
All right, so the big picture.
Now, I'm going to have to admit that I haven't spent any amount of time with formal diagramming.
Mm-hmm.
There is such a thing, UML, but I don't. I find it obnoxious because to be honest, because I sort of find diagramming a useful tool for my own personal benefit and to explain it to other people. You can argue that a standardized way of diagramming things is essential for communicating with other people, but I find more free-form sort of diagrams makes a lot more sense when you're sitting down and talking to the person. So the first diagram that I kind of want to show is going to be like the 4 projects, I guess you could say.
Okay.
The engine, the query graph, the UI, and the card definitions. And I call those projects, but really only the first 3 are going to correspond to projects. But you can kind of think about them as just different areas of where the code is going to exist within our solution.
So you had the engine, you had the query graph.
Then the UI, and then the card definitions. And the engine and query graph are almost exclusively in the UI, for that matter, almost exclusively going to be runtime code. The card definitions are going to be a mix of both runtime and game initialization code. Now, the engine is just going to be a bunch of classes that talk to each other. I'm not really going to go into detail about what each class is going to be. But you can think about the engine as sort of a black box that contains a bunch of classes that talk to each other in the normal OOP awesome way. But the important thing to know is that the engine is going to be a black box to the rest of the system. Because one of the primary reasons is both reducing complexity, obviously. Once we sort of establish how the engine talks to everything else with very well-defined channels, things become a lot simpler. In addition, every bit of communication that the engine does over to the query graph and the UI and the card definitions, that needs to be serializable. Jason, help me out. Serializable?
Sounds great.
It'll work.
It works. Keep going.
It has to be serializable and sent over the wire if we are going to implement multiplayer. Because in a multiplayer situation, one player is going to be the host. He's going to be running the engine. And the engine is going to have to shoot off these messages to the query graphs and UIs and not card definitions, but the query graphs and the UIs of all the other clients over the wire. So that's so like I said, it's the 2 reasons that I'm doing it this way are for simplicity and for the ability to go over to networking in the future. It is a word, I just may not be pronouncing it properly.
All right.
So yes, the engine is just that. The query graph is also very important. The query graph is just going to be another model of classes. Just going to be another group of classes that have their own little relationships. But the interesting thing about the query graph is it's not going to have any behavior inside of it.
So if you guys hadn't noticed, my idea of classes that have relationships is just a bunch of boxes with lines connecting them.
Yes, that works.
So if you're wondering what in the world it is I'm drawing, that's what I'm drawing.
So the responsibility of the query graph is to be incredibly simple and straightforward. They're just going to be a bunch of classes that have some relationships that you can navigate across to inspect the state of the game. The query graph represents the current state of the game in a very simple and straightforward data model. Also, most importantly, or not most importantly, but in addition and very important, but perhaps not important as the other few points, is that the query graph classes are going to, if any of you are WPF developers, we're going to be using the MVVM pattern. Every class in the query graph are going to handle the I notified property changed event, so it'll be directly wire upable.
I'm not going to write that.
To WPF. Just say like WPF friendly or MVVM friendly.
Okay.
And MVVM stands for model view model, and we'll talk about that obviously once we get to the UI, unless you already know what it is. But we'll probably talk about that anyway. So
now,
yes.
earlier you were saying in terms of the engine that all the info that goes in and out of it is going to be serializable for networking. Does this basically mean that this is where your network separation is going to exist?
Yes, for players that aren't the host.
Okay.
Now, for players who are the host, the engine is going to be talking with the query graph of that particular player, but the clients are going to be shot off the data.
Okay.
And we'll draw the lines about how the engine does interact with everything else in a little bit.
Okay.
After the UI, that's just the UI. So
Sure. Just draw like a really cheesy kind of
box thingy.
box, you know, and it's got stuff, and it'll have like cards on it,
Best UI ever.
and then it'll have information on it in the chat window where you can tell your friends like, "Hey, WTF." So okay, there's our fantastic UI, best UI ever.
Okay. And then we have finally the card definitions.
Okay.
The card definitions are just going to be classes, and they're not going to be. It's not going to be a data or object model like the engine and query graph. They're just going to be standalone classes.
Stand on their own.
And they're going to be. There's actually going to be 2 classes per card. And when I say card, I don't mean a physical card that I might purchase and look at. I mean the abstract concept of what makes a particular magic card a particular magic card. That is the card definition, and it is a class. So card definition is just an abstract concept that represents a card that could exist. I don't know what I'm going to be calling this other type of object, but there's also going to be a corresponding class for every particular card that represents the runtime behavior of that card. And every single one of the cards as the game is being played, every card on the game board or in your library, in your hand, wherever, is going to have an instance of this class. So in reality, every card definition is really 2 classes.
Okay.
That are linked somehow or associated with each other. We'll actually be using the abstract factory pattern with that to make things more straightforward. But yeah, so that's basically the 4 main kind of components of the system.
What if I'm just trying to be consistent with my note taking here? What can I fill into this great big gap for the UI? What's the responsibilities of the UI in this case? I mean, is it just there to present the data from the engine? Is it also going to be sending out any data on its own?
Well, the UI is going to be primarily it's going to be representing the current state.
Let's say it visually represents the current state, because that's kind of the same thing we said about the query graph.
Yes, visually. It basically takes the data out of the query graph and represents it as in a UI. Obviously, it's a UI.
Yeah.
And it also, we'll talk about this actually almost immediately, the engine still has to have a sort of means of asking the UI questions. And so the UI is kind of, you can think of the UI, we're using the word UI here because that's the concrete thing that this represents. But in reality, it's secondary responsibilities to be sort of a driver, to be sort of a thing, a class, or a something, a black box, another black box, that gets asked questions by the engine and returns responses. And that constitutes gameplay.
Okay.
So if that makes sense.
Yeah.
Okay, so as far as how everything gets communicated, the engine is going to obviously have all the game logic in it, or most of the game logic in it. The overarching concept of the game is going to be contained in the engine. The particular cards and how they behave in the system are going to be handled with the card definitions. The engine, every time that something changes within the engine, like let's say a player loses life or something happens that constitutes a state change in the system, what happens is that the engine is going to shoot out events. Now, those events
Where are they going?
They can go anywhere.
Okay.
For the most part, they're going to go into the query graph. The events are going to get fired into the query graph. The query graph is then going to update its own internal representation of how the game is being played. That's going to trigger the iNotify property change for the MVVM, which is in turn going to update the user interface.
Okay.
The card definitions also get to listen to events. And that's because there's lots of cards. You should probably actually start that line from the engine.
Oh, okay.
That would probably make more sense.
Make sure we're talking about the same line. You know what I'm saying?
Okay. Well, if you're going to draw from query graph to the UI to represent the iNotify property change, then yeah, that makes sense.
So this is going out to the card definitions?
Yes.
Hang on one sec, Nelson. You're definitely becoming pretty strong Cylon at the moment.
We may have to pause for a moment and reconnect with you.
Okay.
All right, let's see if that comes around. You still there, Nelson?
Yeah, we paused.
All right, hang on. No, not yet. Yeah, I guess we're going to have to. Hang on one sec.
Blow your mouse for a sec.
That's okay. Zach, we're back, ladies and gentlemen. So we didn't have to disconnect. Let's just see if things hold up. Nelson?
Okay, so I was saying words.
Yes. We've transmitted some events from the engine to the query graph as well as to the card definitions. Now, just to clarify, and you might have already said this, maybe the pause kind of blanked my memory. Can you give me an idea of what types of events are going to be sent from the engine to the card definitions?
Anything that... Okay, so imagine you're playing Magic.
Easy enough.
Imagine you're playing Magic, you're sitting there with another person, and then something happens. Like you lose life, or a creature gets a counter, or you tap something. Something happens that makes the game board look different than it did before.
Uh-huh.
That's going to be an event. An event's just going to be a little class that contains some properties that's going to be shot wherever it needs to go.
Okay.
And the primary thing that's going to go is into the query graph, which is in turn going to update the user interface. The card definitions, however, also need to listen to events. Because a lot of cards, especially enchantments, do things based off of something that happened in the game. Like a player, like Sanguine Bond, for example. I believe that's whenever you gain life, your opponent loses that much life. So obviously a card definition of Sanguine Bond is going to have to listen to the player life changed event and then do something based off of that.
Okay.
And so that also brings in the next line that you're going to have to draw. And that's from card definitions back into the engine.
Okay.
The issue with this that I had with this, and this particular line kind of upsets me, because it's just it's
dashed, isn't it? I understand.
No, just because it's a tad redundant, because we already have this object model in the engine. The problem is that I want to treat the engine like a black box. Also, I don't want the card definitions, because they're going to be existing in a separate assembly during runtime, I don't want them to have direct access to the engine. I also don't want it to be too complicated. I don't want people to mess around with the engine directly to make something invalid happen. So instead, we're going to also have to abstract the idea of the card definitions doing something that affects the engine. So think kind of the reverse of an event.
Okay, an anti-event.
In CQRS, it would be called a command. So the commands would be stuff like have player lose life. What that'll do is that'll get sent into the engine from a card definition. That'll be sent to the engine, and the engine will then take that command and then perform actions on its own stuff inside of it, perform actions on its own classes, determine if that action was legal, then perform it. And then when it performs that action, that in turn turns into events. Those events are then, again, shot out. They hit the query graph, and then they hit the card definitions again. Does that make sense?
Yes.
Mm-hmm.
So how much are you following this, Jason?
That's fine. Makes complete sense so far.
Okay, now there's one last really big problem with this. There's two last really big problems with this, actually. The first problem is that the card definitions, they're either going to need a copy of the query graph or direct access to the query graph.
Okay.
I haven't decided what I'm going to do with that yet. But basically, cards need to query the state of the game that, like, for example, allies. Whenever an ally enters the battlefield under your control, stuff happens, right? Well, the cards are going to have to know how many allies, for example, on Ducleric. Whenever on Ducleric or another ally enters the battlefield under your control, you may gain life equal to that much, how many allies you control. In that case, the on Ducleric card definition is going to have to query the game to see how many allies do you control right now, and then send a command saying, have the player gain this much life.
Okay, so the card definitions are going to need access to the query graph. Which way should this arrow be pointing?
It should be...
Or is it kind of a both-way kind of thing?
Yeah, it's actually just... Well, it's not both way. It should be... what do you think, Jason?
With the way that he's representing it with this kind of a diagram, I would just put the arrow pointing towards the query graph. He's gaining access to it. Now, what's the problem, or what are you anticipating the problem being if you were to provide access to the query graph?
It's the issue with that is that the query graph and the UI are tightly coupled.
Correct.
By design, they're tightly coupled. I don't necessarily want the card definitions to be tightly coupled with something that's also tightly coupled with the UI, because the UI is always subject to change. So that's why I'm saying there might be a duplicate query graph, or there might be simply different objects that are reinstantiated for the query graph. One set of objects being used for the UI, the other one being used for the card definitions. I'm not exactly sure how I'm going to figure that out, but that's my issue with it, is that it implicitly couples card definitions with the UI, which is something that I don't want to happen.
Okay.
But like I said, there's really no alternative because the card definitions need access to that. And I don't want to couple the card definitions to the engine, especially because the engine's very much subject to change. Whereas a card definition, we're going to be spending probably even a decent amount of time writing those things, even for the very few cards that we're going to be implementing. Mm-hmm. We don't want to have to go in and change that every single time we make an update to the engine, or every single time we make an update to the UI that constitutes an update to the other query graph.
Right. Of course not. Okay.
So, yeah. The final thing, so that's all great as far as how information flows when things happen, but there's really there's nothing that's sort of driving this. There's no driver in the system right now. Nothing will happen if we just implement all these objects how they're laid out. And that's because there's no way for the UI to tell tell the engine anything. You see that there's no line from the UI to the engine. The UI will never have direct
Hang on
access.
1 second, Nelson. It seems that we actually have somebody here. Okay, Nelson, sorry about that. We're good to go.
Yes, so right now the system is completely static. There's where does the player fit in, I guess I could say. And that's going to be handled with a system of questions and answers, I guess you could say, that originate from the engine and go into the UI. So when the game starts on the engine, that's where the .start method or the .play method is going to be. It's going to shoot off a DTO, so just a normal serializable class with some properties on it, asking the UI something. And it's going to be something like, what ability do you want to activate? Or do you have any responses for the ability that another person just activated? Or what creatures do you want to tap to attack? Or what creatures do you want to use to block? This is going to be the sort of heartbeat of the entire system, is going to be this question and answer system, where like I said, the engine asks the UI something, and then the UI in turn responds with something, and then the engine then performs logic based off of the response from the UI, which in turn kicks off events, which go into the query graph, which are then rendered by the UI. And the events obviously also go into card definitions, which get turned into commands, which go into the engine, which should get turned into events. And you see
Yeah, that's actually not bad.
And I drew those solid because they're so important, because that's like your heartbeat of the whole system right there.
Yep, that's how the system. Yeah, and this is something that just popped in my head actually. Well, I was thinking about this today. This UI, I kind of almost want to rename him. There'll still be a UI, but the thing that responds to the questions and there's questions and answers. So the UI is still there. He still reflects what's on the query graph. But the thing that responds to the questions, or responds to the questions that the engine poses, would be something called like an iDriver or something, or an iGame driver. And by default, it'll just delegate to the UI. But this would be where we would put artificial intelligence in the game.
Oh, look at you go.
So that's just like the single point that we would need to extend if we wanted to add AI into this entire system.
Very cool.
Because again, those are the only choices that players make.
Right, absolutely.
Awesome.
So as far as the big picture goes, is this pretty much it then?
Yes.
Okay.
Well, I mean,
yes.
As far as the big picture goes,
At this point.
At this point, yes, that's it.
Yeah, to be fair, because this is going to be a continued work in progress. So then we can go ahead and wrap this video up as a look at the big picture, and then in the next video, you're wanting to take a look at what, pregame?
Yes, I want to go over the pregame environment, whatever we end up calling it, the concept of loading cards into the system so that they can be used.
Okay. Fantastic. Then thank you guys very much, and we'll go ahead and wrap this video up, and we'll see you guys in the next.